Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform. I am your teacher, Mwaniki Nyaga. The subject is chemistry and our topic is energy changes in physical and chemical processes. Today, we are going to define 3 terms. The first term is energy. The second term is chemical process, and the third term is physical process. Our first term, which is energy. Energy can be defined as the ability to do work or ability to cause a change. The ability to do work or the ability to cause a change. That is the definition of energy. There are various forms of energy which include electrical, heat, chemical, they include the electrical energy, the heat energy, the chemical energy, the kinetic energy, and the electrical energy. So those are our 5 forms of energy or examples of energy. Energy can neither be created nor destroyed. So you cannot be able to create energy and you cannot be able to destroy energy. You can only convert this energy from one form to another. For example, you can convert heat energy to kinetic energy. So you can convert this heat energy to kinetic energy. Another example is that you can be able to convert the kinetic energy into electrical energy. So you can convert this kinetic energy into electrical energy. So you cannot create energy and you cannot destroy energy. The second term is physical process. And you see that a physical process is a process which does not lead to formation of new substances. So it is a process that does not lead to formation of new substances. So the substances or the substance before will always be the substance at the end of the reaction. For example, we have zinc oxide. Zinc oxide is a solid, and this solid is white in color. So when you heat zinc oxide, so what is going to happen, the color of zinc oxide will change from white to yellow. When you cool this yellow zinc oxide, which is now hot, it will now turn back to the white solid you had initially. So you'll have an equation which looks like that. So these two arrows facing opposite directions means that this reaction is reversible. So it is a reversible reaction, meaning that from the initial products, when you heat zinc oxide, which is white in color, then you get yellow zinc oxide, which is now hot. Then when you cool that hot zinc oxide, you can be able to get the white zinc oxide at the beginning of that experiment. So here you are heating, then here you are cooling. The third term is a chemical process. Chemical process. A chemical process is a process that leads to formation of new substances. So it is a process that leads to formation of new substances. An example we have copper 2 nitrate. Copper 2 nitrate is a blue solid. So when copper 2 nitrate is heated, you get a black solid, which is copper 2 oxide. A brown gas is produced, which is nitrogen 4 oxide, and a colorless gas is produced, which is oxygen gas. Heating copper 2 nitrate. So heating copper 2 nitrate. So the chemical formula of copper 2 nitrate that is the chemical formula of copper 2 nitrate. Copper 2 nitrate is a solid. When you heat copper 2 nitrate, so the products are copper oxide, which is also a solid. We have nitrogen 4 oxide, which is a gas, and we have oxygen gas. So that is our chemical equation showing heating of copper 2 nitrate. But because the equation is not balanced, then you need to balance the equation. So we balance the equation by ensuring that the number of atoms on both sides, that is now the reactant side and the product side, are the same. So we have one copper atom here, then you have one copper atom the other side. The nitrogen atoms, we have two, because this is 1, 2 times 1, those are 2. Then here you have 1. Then oxygen atoms, they are 2 times 3, which are 6. On this side, we have 1 plus 2 plus 2. Those are 5. So oxygen atoms are not balanced. The nitrogen atoms are also not balanced. So we balance the equation by putting a 2 before copper 2 nitrate, another 2 before copper 2 oxide, and a 4 just before nitrogen 4 oxide. So we have placed 2. So 2 just before copper 2 nitrate, 2 before copper 2 oxide, then 4 before copper, not copper, but nitrogen 4 oxide gas. So the equation is now balanced like that. So the reason why it's balanced, copper, initially it was 1, and 1 on the reactant side, then 1 on the product side. So by introducing 2, copper element now remains balanced, just like it was before. We go to the next element, which is nitrogen. The nitrogen atoms on the reactant side, this is 1, and there's a 2 just outside the bracket. So 2, you multiply by 1, you get 2 atoms of nitrogen. Then the 2 atoms of nitrogen in here, you multiply by these 2, you get 4 atoms of nitrogen. That is now on the reactant side. On the product side, we have 4 nitrogen atoms. So these 4 multiplied by 1, those are 4 nitrogen atoms. So the nitrogen atoms on the reactants and the product side are also balanced. Our next element is oxygen. Oxygen atoms, these are 3 oxygen atoms. You multiply by 2, which is just outside the bracket, those are 6. You multiply by these 2, making them 12. So there are 12 oxygen atoms on the reactant side. So 2 times 3, which is 6, then 6 times 2, which is 12. Then on the product side, we have oxygen, 2 times 1, making 2 atoms of oxygen element. So those are 2. Then here we have 2 atoms multiplied by 4, you get 8. So 8 plus 2, those are 10. Then lastly, we have 2 oxygen atoms at the end. So 2 plus 8 plus 2 makes them 12. Reactant side, there are 12 oxygen atoms. Product side, there are 12 oxygen atoms. That equation is balanced. That is an example of a chemical equation or a chemical process. Once this reaction has taken place, then it cannot be reversed back. You cannot be able to get the initial product or the initial substance from the products, because nitrogen 4 oxygen gas and oxygen will have escaped into the atmosphere. So this one you need heat so that the heat is now going to decompose copper 2 nitrate solid to copper 2 oxide, nitrogen 4 oxide, gas and oxygen gas. So said that copper 2 nitrate is blue in color, copper 2 oxide is black, nitrogen 4 oxide is a brown gas, then oxygen gas is a colorless gas. So that is our first example. Our second example will be heating magnesium solid in oxygen. So you are heating a magnesium ribbon in oxygen. The formula of magnesium is like this. Magnesium, the physical state of magnesium is a solid. So it is denoted by a small s. Then it is reacting with oxygen gas. That is the formula of oxygen gas. So the physical state is that it is a gas. Then once the reaction takes place, magnesium combines with oxygen, leading to formation of magnesium oxide. And the formula of magnesium oxide is like this. Magnesium oxide is a solid. So just like the initial equation, this equation is also not balanced because we have one magnesium atom here and one magnesium atom on the product side. So the magnesium atom is balanced, that equation. Oxygen element is not balanced because we have two atoms of oxygen element on the reactant side. Then you have one oxygen atom on the product side. So to balance that oxygen element, then you need to put a 2 just before magnesium oxide. When you put the 2 just before magnesium oxide, then the magnesium atoms will now rise to 2. It was 1, now they are 2. So 2 times 1 now makes magnesium atoms to be 2. Then oxygen atoms, they are 2. So this is 2 times 1, now making the oxygen atoms to be 2. So you now check whether the equation is balanced. So on this side, we have one magnesium atom, which is the reactant side. You have one magnesium atom. Then the product side, you have 2 magnesium atoms. So you find out the magnesium atoms are not balanced. So we just need a 2 just before the magnesium element. So the magnesium at this time are now balanced. You have 2 magnesium atoms on this side, then you have 2 magnesium atoms on the product side. Go to oxygen element. Oxygen, we have 2 atoms on the reactant side. Then on the product side, we have 2 oxygen atoms. 2 times 1, they are 2 oxygen atoms. So the equation is now balanced. So the difference between these chemical processes and the physical processes is that a chemical process is an irreversible reaction. An irreversible reaction is a reaction which, that once it has taken place, you cannot get the initial products. Like for example, you cannot get copper nitrate from copper, nitrogen, oxygen, and oxygen because these gases have already escaped into the atmosphere. In the second one, you cannot get magnesium and oxygen, or you cannot be able to separate oxygen and magnesium from each other because it is a chemical reaction. A chemical reaction has already taken place, so we cannot now separate the two because it has formed a new product. And that's why we said that a chemical process, it is a process that leads to formation of new substances. So new substances have been formed, and so you cannot get the initial products from, or the initial reactants from the products which you have gotten. That is the definition of our terms. Make sure that you remember the definitions, that is energy, a physical process, and a chemical process. So I have an assignment for you. So state 4 differences between physical and chemical processes, which of course we have already given one, which you have said that a physical process is a reversible process and a chemical process is an irreversible process. So ensure that you get the 3 other differences between the physical and the chemical processes. So next time we'll talk about the endothermic and exothermic reactions. Thank you.